with autonomy. So there's some debate as to what that number is, but it's some number less than the number of vehicles needed today. There's roughly 2 billion cars and trucks in operation in the world today. And
yeah, so what we show here is actually, I think, only 1.4 million or so. So we're represent 1.4 billion, I mean, or so. So a smaller fleet, and you know the numbers are here in this presentation are around 85 million vehicles a year produced. Just to give you a sense of how we're thinking about this. Again, we're going to put all these assumptions up online and encourage people's thoughts.
Yeah. So we're basically heading rapidly towards an electric or autonomous future.
Exciting.
Yeah.
And one of the reasons why EVs are so enabling is this end-use efficiency point. Tesla Model 3, it's 4 times more efficient from the well to wheel than a Toyota Corolla. And that's all about the efficiency of getting the electricity into the car in a sustainable energy economy, and then how efficient the car is in transferring that stored energy to motion on the road. When compared to the engine in the Toyota Corolla and all the extraction, refining, transmission, distribution of the gasoline to the Toyota Corolla. And just for, this is a fun reference, Model 3 can drive over a mile on the energy it takes to boil a pot of water for pasta, and then it can drive another mile on the energy it took to cook the pasta. And that pasta is 1 pound, and Model 3 is like 4,000 pounds. Just to give you a sense of just like, it really doesn't use a lot of energy to move a Model 3, that 4,000 pound object, down the road.
Yeah, also, heat is a lot more energy than motion.
Yeah. Yeah. But people, you just boil a pot of pasta, you don't even think about it. It's just interesting how efficient these cars are. Next, switching to heat pumps in homes, businesses, and industry. Right now, heat pumps meet 10% of building heating needs. Install rates growing 10% year on year. It really needs to accelerate. Heat pumps can serve, heat applications up to 200 C in businesses and industry. And from an investment perspective, as you can see on this page, this is actually the lowest hanging fruit in terms of displacing fossil fuels. You might be saying, well, what exactly is a heat pump? So heat pumps don't move heat, don't create heat, they move heat. When you think about like the natural gas furnace in your house, it is generating heat itself, but what the heat pump is doing is actually moving heat from outside of your house into your house. They're just an air conditioner or a refrigerator in reverse. So we're surrounded by heat pumps. There's they're all over this factory. They're in your house. And all this really is about bringing them to displace all the fossil fuel heating in all of the homes, business, in the industry that we can. And from an end-use efficiency perspective, there's a three times reduction in the total energy required to heat these buildings. So a real obvious thing to do.
Yeah, heat pumps. They're in our cars, now as default. And at some point, we might make a heat pump for our home. So
yeah, maybe. Next, a little bit more detail on electrifying high-temp sort of industrial chemical processes. So over 50% of industrial heat is greater than 400 C. Cement, steel, fertilizers, chemicals, plastics, metals refining all need like 1500 C, so we need a solution here. Ultimately, it's purpose-built equipment that enables electrification. Carbon graphite is stable up to 2800 C. There's other options in the 1500 C range, like silicon carbide, other materials. So the idea here is you create and store heat when renewable power is available. If this is a sustainable energy economy, renewable energy is intermittent. Peak of the day, you've got more generation than you need. You make a bunch of heat then, and then you transfer that heat into the industrial process 24 hours a day using the stored heat you created when the sun or the wind was blowing. That's the concept here. And then on the hydrogen side, we also need green hydrogen to decarbonize metals and chemical refining processes. This is things like ammonia, making steel. There's roughly 120 million tons of hydrogen sourced from fossil fuel today to do these things. And hydrogen can also directly replace coal, which is currently used in a ton of steel production, through a process called directly reducing iron. You can replace blast furnaces with a hydrogen-reducing, direct reduced iron furnace. And this is the way to eliminate fossil fuels from these aspects of the economy and the CO2 associated with them.
Yeah, so some of this, there's like room to disagree, but some amount of hydrogen is needed for industrial processes. My personal opinion is that hydrogen will not be used meaningfully in transport.